All right, guys, welcome back. This is going to be the 9.5 instructional video. And 9.5 has one of the most important topics of algebra. We're going to hit that hard. So pay close attention as we travel through this and be really diligent about starring your notes, letting me know what questions you have, and all of that sort of stuff. Okay. So far, and you can go ahead and try this on your own, distribute the following binomial. We have a binomial times a binomial. I want you to go ahead and multiply it out. So pause the video and do that. Well, in that multiplying out process, you should be very familiar with our arrows or our rainbows by now. We multiply each term in the binomial by the other terms. And we get x squared plus 5x plus 3x plus 15. We combine our like terms. Remember, like terms in polynomials, same base and same exponent. And we get x squared plus 8x plus 15. But what I want you to look at is I want you to pause the video. And I want you to look at 8x and what we started with and see if you notice a pattern. Okay, now that you've done that, again, look at 15 and see what you notice with the original. Well, now that you've paused the video and you've looked at it, hopefully you see a little pattern there. You notice, hopefully, that 3 plus 5 gives you 8, whereas 3 times 5 gives you 15. And no, this isn't just a happy coincidence, and it's going to be the basis of what we talk about today. If you look closely at the trinomial we found when we distributed above, the two numbers, that trinomial, by the way, was x plus 3 and x plus 5. Or the two binomials multiplied together to give you the trinomial was x plus 3 times x plus 5. The two numbers that sum to be the coefficient of the middle term were 3 and 5. Remember, we came up with the trinomial x squared plus 8x plus 15. And 3 plus 5 gave us 8, which is that coefficient of the middle term. The two numbers that multiplied to give you the constant, 3 times 5. And so when we think about this, and when we notice this pattern, and when we think about the process, or the original process we did, this should make sense. When I'm distributing, I multiply. My last step of my distribution is to multiply and get 3 times 5, which is 15. And what I do is I multiply 3 and x and 5 and x in the middle there, and then I end up adding 3x plus 5x to get 8x. So noticing this patterns, what does this mean for us? Well, in 9.2, we discussed about factoring and how it's the opposite of distributing. Factoring for us is the process of taking a polynomial, like the trinomial we saw above, x squared plus 8x plus 15, and finding the original factors that make it up. So we already learned how to factor back in 9.3 or 9.2 when taking out the greatest common factor. Now we're going to learn another way to factor trinomials. So how do we factor a trinomial? Well, we're going to find the two numbers that add to give us b and multiply to give us c. And you might be wondering, b and c. Well, trinomials in their general form look like this. Ax squared plus bx plus c. And what we saw above is that when we multiplied out our two binomials, when we do that, we could find 15, which according to our general trinomial formula is c. We could find 15 by multiplying the second term in each binomial. We could also find b by adding the coefficients of the two terms in the binomial. Okay? And this pattern that we observe, we are going to use to help us factor future trinomials. Okay? So now that we have the idea on how to factor a trinomial, finding two numbers that add to give us b and multiply to give us c, let's go ahead and try an example. Let's say we have x squared plus 7x plus 12. Well, according to my definition, and if you don't remember it, look at the definition you've written down on your paper. According to my definition, I am to factor by finding two numbers that multiply to give me my last number and add to give me my middle number. So how do we start this process? Well, what we're going to do is we're going to first look at all the factors of 12. And then we're going to choose the factor out of our C, our term C, our constant in this case, that we're going to choose the term or the two factors out of that constant that add to give us our middle term, and that will be our factors. Okay? So what we're going to do, let's identify the factors of 12, and we can do this by making a factor tree. We have 1 times 12, 2 times 6, 3 times 4, and you want to make the factor tree until you cross the middle. What do I mean by that? Well, after 3, I'm going to get into 4, and I've already identified that as a factor, so I know that I can stop at this point. And so what I'm going to do is look at this list of factors and identify which ones add to give me my middle term. Well, 1 plus 12 would give me 13. 2 plus 6 would give me 8. But 3 and 4 will add to give me 7. Therefore, 3 and 4 are going to act as my two factors. So how am I going to write this out? Well, I'm going to take those two factors and I'm going to put them in parentheses that are multiplied together. Doesn't matter which one goes where. And this will be how I write out my factors. The reason I'm writing them next to x's is when I multiply this out, my goal should be to get the original. In fact, this is how we can check our work. If I write my answer as the multiplication of two binomials with these factors, then when I multiply this out, I should get the trinomial that I started with. Well, x times x is x squared. X times 4 is 4x. X times 3 is 3x. And 3 times 4 is 12. Combine your like terms, and I get x squared plus 7x plus 12, which is my original trinomial. And so I know I've found my factors correctly. So the process you're looking to do each time. Number one, we're going to look for the factors that add to give us our C term, or that, multiply to give us our C term, our constant. And then we will look to find out of those factors the numbers that add to give us, or the variables in some cases, that add to give us B, our coefficient in the trinomial of the middle term. And then once we find the numbers that do that, we will write them in the form of two binomials multiplied together. Okay, let's try another example. We will do x squared plus 21x plus 20. And pause the video at this point. See if you can find the two factors for this trinomial. Well, we're going to start the process by making a little factor tree of our constant C. So I know 1 times 20 gives me 20. I know 2 times 10 will give me 20. Now 3 does not divide nicely into 20, so we'll skip that one. 4 times 5 gives me 20. And at this point, I have crossed the middle, where I'm starting to, if I would try and do 5, I've already hit that factor, and so I know I have covered all the potential ones that go into 20. So what I'm going to do is I'm going to now identify out of my list of factors which ones add to give me 21, and that, of course, would be 1 and 20. And so now I will write them as a product of two binomials, with the first term in each binomial being x, because that will give us the x squared. And if I wanted to triple check my work, I could multiply this out. And what I would find is that I will indeed get x squared plus 21x plus 20. Okay, so if you're struggling at this point, if you're still pretty confused about what I'm doing, go ahead and pause the video, make a little star, and say, hey, Mr. Carter, I was watching the video. I'm kind of confused about what you're doing, and I will help you out. So let's do a couple more examples. Let's do d squared minus 17d plus 42. Now things get a little bit trickier. Okay, the process isn't going to change, but we have to look at these with a more keen eye because we have introduced a negative. We have introduced a negative. So what's that going to mean for us? Well, the process is still the same. Let's go ahead and find our factors of 42. 1 and 42. 42 is divisible by 2. 2 and 21. By the way, if you can't do these factors in your head, that's okay. Use a calculator to help you out. 3 divides into 42 and gives us 14. 4 does not divide nicely into 42, and neither does 5. But 6 will divide into 42 and give us 7. And again, at this point, if I would continue, my next factor would be 7, which I've already listed. Therefore, I am okay to stop. Now, the problem I run into is I've made this list of factors, and I go, none of them give me negative 17. 1 and 42, 2 and 21, 3 and 14, 6 and 7 do not add to give me 17. Or negative 17, excuse me. So what am I going to do? Well, the thing is with factors, these factors don't necessarily have to be positive. The one requirement for these factors is that they multiply to give you positive 42, right? Positive 42 because we have the plus sign there. Now think about this, pause the video and think about, how can I multiply two numbers together and get a positive without them both being positive? Seems like a silly question, but how can I multiply two numbers together and get a positive without both the numbers being a positive? Well, what I hope you're remembering is, yes, positive times a positive equals a positive, but I also can do negative times a negative equals a positive. And so no matter which one I do, either way, my factors just need to have the same sign. I can do positive 1 and positive 42 and get positive 42. I could do negative 2 and negative 21 and still get 42. That's positive. Now, why is this important? Because I need to find a way to get negative 17. I need these numbers to add to be negative 17. Well, it's never going to happen if they're both positive, but maybe it's possible if they're both negative. Well, let's look at them. Negative 1 and negative 42 gives me negative 43. Negative 2 and negative 21 gives me negative 23. And again, if you're not great at adding negatives or subtracting or working with negatives in general, double check your work with a calculator. Try it in your head, but double check it with a calculator. But what I notice is negative 3 and negative 14, hey, that gives me negative 3 minus 14 or negative 3 plus negative 14, depending on how you look at it, gives me negative 17. So how am I going to write this out now that I've identified my factors, two factors that multiply to give me C and add to give me B? Well, I need the letter D to start with as my first term in each binomial. That way I get the D squared. And then I'm just going to write them in, but I'm not going to write plus symbols because they are negative. D minus 3 and D minus 14. And even more important now so than before is to check your work, especially when you notice a negative in your initial trinomial that you're looking to factor. Check your work by multiplying out the binomial. D squared minus 14D minus 3D plus 42. And that negative 14 and negative 3 are going to combine to give me D squared minus 17D plus 42. So the process is the same. We just have to think a little bit deeper when we're working with negatives. And we'll get to those rules in a second. But first, let's try another example. Let's try your hand at this. This last one I led you through pretty solidly, but after I write this problem down, you go ahead and pause the video and see if you can figure it out. X squared plus 6x minus 27. X squared plus 6x minus 27. We'll start the process out the same. Hopefully you've paused it, you've taken a shot. If you haven't yet, go ahead and do that. We need to come up with our factors that multiply this time to give us negative 27. We'll worry about that negative in a second, but let's just think about 27. We know 1 and 27 will obviously are factors of 27. 2 doesn't go into 27, but 3 does, 3 and 9. 4 does not, 5 does not, 6 does not, 7 does not, 8 does not, and we are at 9, which you've already listed, so we have checked all the factors. And so now let's talk about this negative. Let's talk about this negative. You see, we need two factors that multiply not to give us positive 27, but negative 27. Well, let's think in general, how do we multiply to get a negative number? Well, I have to do negative times a positive or positive times a negative. Either way, my factors, one needs to be positive and one needs to be negative. Now, how do I determine which is which? Well, I'm trying, and this is where we focus on the b value, our coefficient of our middle term. What value, or this is where I need to figure out how to get positive 6 out of my potential list of factors. So I know that the factors have to have opposite signs. One is going to have, if 1 is positive, 27 will be negative, or vice versa. If 3 is negative, then the 9 has to be positive. And how can I create positive 6 out of that? Well, hopefully you rule out 1 and 27. That no matter what combination you look at, it's not going to give you the number 6. But 9 and 3 will. We just need to think very carefully about it. Here's why. I need to get positive 6. So if I need to get positive 6, then I need the 9 to be positive and the 3 to be negative. If I would have gone the other way and made the 3 positive and the 9 negative, that's going to give me negative 6, which isn't what I want. I want positive 6. So I need to do positive 9 and negative 3. So I'll write out my factors as x minus 3 and x plus 9. But again, check your work here, folks. I can't stress that enough. Multiply this out and check your work. When you do that, you get x squared plus 9x minus 3x minus 27. Again, we can see here by the choice we made that positive 9 and minus 3 is going to give us that positive 6x we're looking for. So again, the process isn't that different with the negative. We just got to think a little more. Okay, this is another great marker to check yourself. We're going to do one more problem. And I really, if you haven't yet to this point, I would really challenge you, try this on your own. See if you can figure this one out. Let's do not that one. So go ahead, pause the video, and see if you can figure this one out. Well, we need to identify the factors of 36. So we have 1 and 36, 2, 18, 3 and 12, 4 and 9, 5 doesn't go into 36, and 6 and 6. And at this point, we've hit all of our factors. Now, I need this not just to be 36, but positive 36. But I notice my middle term's a negative. Well, no combination of positive and positive is going to add to give you a negative number. But we know that a negative times a negative will equal a positive and can give us that negative middle term we're looking for. So all these factors, both factors have to be negative to meet the criteria that we get multiply to get positive 36. Well, now looking at my list, negative 3 and negative 12 will give you that negative 15 you are looking for in that middle term. Negative 3 plus negative 12 gives you negative 15. And they will still multiply to give you positive 36. So how are we going to write it out? X minus 3 times x minus 12. And to summarize our rules for negatives, if you like summaries and you want to know what to do, if the middle term is negative, that's the example you just saw above, and the constant is positive, then your two factors need to be negative. And we saw that there. We came up with two negative factors. Our first and third example with negatives involved in factoring trinomials met this case. But as our second example we saw, if the last term is negative, then one of our factors needs to be positive and the other is going to need to be a negative. Why? Because a negative times a positive will equal a negative. This, again, was the second example. Our last term was negative, and so what we had to do is do positive 9 times negative 3, or negative 9 times positive 3 to get negative 27. And then looking at the middle term, seeing that it was positive 6, clued us in that it indeed needed to be positive 9 and negative 3, and not negative 9 and positive 3. So if the last term is negative, then our factors are going to have opposite signs. One is going to be negative and one positive, and then use the middle term to determine where to go from there. Guys, I thank you for watching. As always, let me know what questions you have, and good luck.